How to go close? Yeah. Yeah. Okay. Good evening, students. Prabhakar here. Are you able to see me? Is that the screen? Yes, but that's nothing coming. The delay will be there, so I'm hiding that. Okay, fine. But what is the actual screen? This is a screen. Okay, so they are able to see me. Yes. Okay, very good. So hope you are enjoying the course, although it's almost towards the end of this module. Um, I'm sure you are having some fun. So I would like to start with some technical questions that you may have. Please ask me those questions, and then let's see whether I'll be able to satisfy your curiosity with respect to some of those queries. Good evening, Prasanti. Good evening, Anand, Innovate, Padmavati. Good evening, Prasanti. I should say yes again. Good evening, and then Vivek. All of you, good evening. So, folks, you can ask me some questions. I hope I'll be able to listen to them, or I should be able to see a type of the questions will be typed there. Okay, so should I start answering your questions already? Prasanti, let me just take your question straight away. Your question is about CAN topology. Why is it not a star topology? Prasanti, just imagine that you are inside a car, okay, and you are somewhere at let's say close to 50% of the overall distance from the headlight to the tail. Okay, somewhere you are at 30 or 30 or maybe 40% away, which clearly indicates there is something ahead of you and plenty of it behind you. Front of you is the engine part, and ahead of that is the headlight, and behind you are the rear seats, and then there is the luggage boot space that you have, right? So just imagine if you run a wire from the headlamp to the tail lamp, it can't be like a star. It should be like a bus. It should be several devices which are hanging off a bus, and many of them tapping into it and putting data into that system. So CAN bus is actually the right definition. It's a bus topology. It can't be a star topology. There are other competing technologies which one can talk about. There you can be others. There are others which support star, but definitely CAN is indeed most natural. That it only supports a star topology. This is the first part. The other part is it's also easy for several let's say ECUs, which are engine control or electronic control units, including engine control units, right? So several electronic control modules to discuss, to exchange data, to communicate amongst themselves if it is a bus-based technology, because several parts of information will be flowing all through the bus, and that gives advanced information for those ECUs which might also not require the data immediately, but may want to latch onto the data at a subsequent interval in time. So that's more the fact that it's indeed a bus topology. So Padmavati, your question was star is one of them. I agree. See, this is more not a networking course. So if you talk about it, generally devices which are being networked, then you can talk about star, you can talk about ring, you can talk about mesh, you can talk about bus, and so on and so forth. But this is very specific to the automotive protocol, and there indeed it is just nothing but a bus topology. So it's called CAN bus. So please note that it is not a star topology. Okay, about other things you have written there, star is a physical layout of connecting the systems or nodes of that is correct, and I agree to that part completely. So this is what I had to say, that indeed it is a bus and not really a star. Of course, there are other competing technologies which also support other type of topology, but definitely we have nothing to do with CAN here. They don't talk about CAN. In the course of this module, you might have come across something called a CAN splitter, which we clarified. See, the CAN splitter will give you an additional ability to make it like a star up to that point. Okay, like a leaf, you can come and connect it as a star up to that point. Let me draw that picture, so that might help you to get a better feel. So let's go and draw it. So take a standard. So let me take this for you, and I will draw this. I will have several devices here which are all on the bus. What I will do now is I will have a splitter here, and on a splitter I can get you two devices. This is a CAN splitter. Clearly there are two devices here, and this now becomes a star, right? This is not the way it is expected to work, but maybe if you have a system where this is another one, so this is CAN device 1 and this is CAN device 2, and this is the one that is actually sitting on the main bus. Okay, so this is not expected to be the way it is expected to be configured. So CAN splitters are there, but strictly you don't want ECUs to pass through splitters and so on. You would definitely like to work on this main bus rather than worrying about any of them with respect to any of these splitters. So essentially, this is what we were trying to say during the course of the course during that module. So that is one part. Then I hope this is clear to you. So let's come to the other question related to Biswajit is asking on how to implement self-updating over. No, let's go one by one. So CAN splitter is done. So the other question is, I'm unable to download the transcripts. I think that we can take it offline. That may be another problem. So I won't at the moment. It's not a technical question, so I'll leave it at the moment. Then let me take the next question from Biswajit, which is how to implement self-updating over the air in any module. Well, I can tell you a few things, Biswajit. In the days when we used to work on embedded devices, there used to be something called a golden image. Okay, so let me go back to the screen, and so let me put back the screen for you there. So let me go to take the second question. So how to do OTA, right? This is over the air. You want to do updates. If you want to do over the air, essentially an embedded system would have what is known as a golden image. This is a golden image. And this is the running image. This is the running image. Your requirement is that you want to replace the running image with a new one because you have some updates, you have perhaps fixed a protocol bug, or you have changed the sampling frequency of sensor, or you have disabled a sensor from sampling, or you might have changed the ADC resolution from 7-bit to 9-bit, perhaps to 10 and 12-bit, whatever. So many changes you might have done to the basic code. That means that you have to replace the running image of the system, which also runs from a flash, by the way. This is also in flash memory. This is also in flash memory. So the golden image here is critical because golden image has the ability to accept any changes that is coming over an air interface. Okay. So essentially, you give a command from over the air, asking the running image to be replaced with a golden image. Now the golden image is up there. And once the golden image is there, you can change, you can update the running image to the new image that you normally put. Okay. By chance, during an update, something goes wrong or a CRC fails and so on, the bare minimum thing that the current running image can do is to revert to golden image. So at any instant in time, golden image reversion is the most important thing. Revert. Because an update should not end up with more mess than what it used to be earlier, right? Often this is what we also find problems in our own mobile phones. You update to the later versions of the stack. A new version of Android perhaps has got released, which has not been tested thoroughly. You update it and then it starts rebooting all by itself, and all kinds of issues start cropping up. There should be a way for you to go back, to revert back to something that is stable, that is something that is working successfully. And in embedded systems, this could be like a golden image. So these techniques are very well known. I can't recall the name of the the one in embedded systems, but we used to do this regularly, and I will try and recall and then let you know how we used to do with the change in changing in different versions of a running image, of trying to do an over-the-air updates of embedded codes. So, but however, you could definitely look up open source several parts which are available, which is essentially which can essentially do this. My struggle at the moment is I'm trying to recall the one that we used in our embedded applications, and I'm sorry I can't recall offhand, although your question is interesting. At the same time, Biswajit, I want to also tell you that, and maybe many of you who are online at the moment, to tell you that this course is really not about hardware. This is not really about, this course is not about changing software or changing in updation or any one of them. There's nothing to do with this course. Okay, they are all aspects related to systems. This course is an advanced IoT applications, and we are only worried about applications and nothing else. All that we said, all that you people have pointed out, many of the questions are related to a system design course in IoT, and particularly this question on OTA is a system design related issue in IoT, and that should be handled separately in another course. I hate to say that because it will be like, passing the buck, and therefore I decided to give you an answer with respect to the fact that this golden image and running image is a very well-known thing, and therefore you could look it up if you are interested. So I'll move on to the next. The next is from Dheeraj Mishra. Dheeraj Mishra, good evening. So your question is, can we use RFID sensors with a microcontroller and count anything and get details on a loaded truck to reduce the timing verification on the checkpost? You're absolutely right. This is possible. You could have each and every item inside a loaded truck, which is RFID enabled, and you should be able to read the contents, read the tags. But the question is, at the checkpost, people are actually examining what is in the truck, right? The contents in the truck. Does it carry explosives? Does it carry what is agreed upon in the way bill? What exactly is contained in it? What is the content in the loaded truck? This is hard problem, and I don't think technology can actually replace the two human eyes, which actually go around and look for, I don't know what all things people carry in their trucks, in a loaded truck. Apart from the main item, so many other side items are carried, which are not supposed to be carried, illegally transporting items. So these have to be checked only by by humans. However, I must also tell you that there are ways by which, let me, I think, organize this screen a little better so that you will not see my, um, uh, no, you'll see my face rather than more. me turn around a little bit so that I can look straight into it. Yes, I think this is better. All right. So, however, it is more important that there are technologies out there which can actually look for things like explosives in a truck. There are non-invasive RF microwave techniques which essentially can be applied to sniff for wirelessly sniff or RF sniff for explosives. This is something that some countries in South America actually use if there are mines, lands which are mined, and then every time you walk over these mine blasts can happen. In order to do that non-invasively, people have tried, and it's a very well-known technology to use RF techniques to do explosive detection. So those are available. Your question is a lot more deeper than what you have asked, Dheeraj Mishra. Let me elaborate a lot more on this. For instance, counting the number of items inside a loaded truck, trivial problem, can be done easily, provided the deepest item inside a completely loaded truck, your RF radiation is able to reach, right? Otherwise, it's not going to work. The tag that is out there, if it is deeply embedded and an RF reader is placed outside, unless the radiation and the required link budgets are available for the tag to power up and then make available its ID, you can't count all the items inside a loaded truck very accurately. This is one thing. Second thing is, you may also want to look at localization. What item is where inside a truck? That is also possible. These are hard problems. Very interesting question. So therefore, while I say it is possible for you to, get details of on a loaded truck, count everything, counting itself may be insufficient in often in many cases, right? This is typical of a factory, for instance. In a factory, you may want to count the number of cartons going out because it may simply contain the same item. But at a check post, a truck loaded can carry different type of items, and including what I said are those which are explosives and so on. So this is really a hard problem if it is at a check post. However, if you narrow down the problem to something that you can handle, nothing like it, I would encourage you to think a little deeper on scoping the problem properly to handle this problem of check posts. I hope it is satisfactory. Let's move on. Now, Padmavati from ECE asked the question, how can we measure anomaly for rash driving for the data given in question 7 of assessment 4? So essentially, the answer is in the forum already out there. Padmavati, you should look it up carefully. You should calculate the acceleration for every speed and time given in the table, and for the acceleration that you calculate, you can find the match in the answers. So I think it is out there. It's quite easy for you. The question really was, I think, it's actually to give away the answer. It's perhaps option number 4. Option number 4 is the right answer. Acceleration rate 3.1 meter per second square, and upper threshold is 3. I think that is the answer. So for the problem statement, I hope Padmavati you are clear about it. But most of the answers are out there. Can you check? If you can check carefully, you'll find the answer. All right, Biswajit Singh, one more thing that related to security on OTA. Oh, absolutely wonderful question again. This is a hard problem, Biswajit Singh. Let's hope that we'll build something and show you as we go along in the next course. I didn't think about it, but yes, security related to OTA is a very critical thing. I did talk to you in the next module on first responders, which is coming up soon. There is a module related to software defined perimeter, and that may well be applied to the security part of the course. So let's hope that some clarity on security of related to OTA will come up in the last week of this course, where there is a section on software defined perimeter. You can actually look it up right in advance. There's nothing to hide here from me as far as just giving you advance notice that there is something on software defined perimeter, which may be very useful for the security part of OTA. All right, that is the next thing. Then, all right. So, Anshul Jha, what effects what effects will the IoT have on infrastructure and smart cities region? Oh, absolutely wonderful question again. There are no success stories. There is a success story of a smart city in Barcelona. Barcelona is considered in Spain is considered to have one of the smart cities. India has been trying very hard to get to one nice infrastructure such that you'll be able to establish a smart city. The IoT will definitely have a huge impact. In fact, roads will be less congested, perhaps, and you'll have green signals often if IoT infrastructure works very well. There'll be less pollution. I'm just dreaming of what should be happening if everything goes well. You would know which are the least polluting routes to take. When you drive, your health will improve. You'll have green signals everywhere because traffic will be managed well. Platooning perhaps in cities will come, and there will be nobody there who will sort of police you all along in a smart city. Ambulances can move freely to their destinations. Then people can commute to office as they feel most appropriate. So many nice things will happen. It will definitely have a huge impact on the overall well-being of humans, and I'm sure you'll have information in advance. See, the whole problem is in most of us, it's also a little bit psychological, and IoT will remove that part very easily. It isn't that you don't mind sitting in a public transport bus or in a train or metro train, for instance, for 1 hour. That's not your problem. Your problem is uncertainty. If I leave my house at 7:55, will I reach office at 8 o'clock or 9 o'clock in the morning? Is the question you ask yourself. Should I take the 7:50 train or should I take the 7:55 train? And if the train does not come, what will happen? What will happen if something goes, completely out and there is a traffic jam somewhere or there is an accident up? These kind of things are what bothers us. Therefore, IoT, it is the best chance for IoT to keep you well informed on what is likely to happen on a particular day at a given particular time. If the train does not come, it should give you information that it's late by 10 minutes. So you may want to take an earlier train to reach your work spot exactly at that time. So you see that 1 hour travel has not bothered you. What has bothered you is the fact that everything has become uncertain, and that uncertainty has now become more certain. So certainty in many of the things that we do is what will ease a lot of tension and pressure on you, and everything becomes a lot more deterministic, and that's where the major advantage. So I'll move on. The next question is from related to LiDAR. How to measure distance using LiDAR? Well, I thought we had explained this quite well in the course, and somebody also asked a similar question on pillar depth measurement, and I'm sure by looking at the data and the exercise we gave you for that week, most of it is well and self-contained. Please spend a little more time trying to understand it, and I'll be very happy to take questions on the forum once again if you're unclear. But I'm pretty confident that the teaching assistants who have been part of this course, Nitesh, then Praveen, Tejaswini, Praveen, and Sanmay, and Vinod Hegde have tried their best to ensure that they brought the questions to my notice, and we have given you all satisfactory answers. This question appears a repeat, and therefore please look up. It is there out there, so that should not be an issue. So Prashanti, once again, sir, in videos explain n-gram model for split speech word into n-1 predecessors. Why GMM model cannot be used for reconstruction of speech words? Prashanti, question is not completely clear. You are asking me why model cannot be used for reconstruction of speech words. See, the GMM model will only taking the essentially the MFCC features and fitting into a word. For continuous speech recognition, you can't use GMM model, Prashanti, because it's moving over time. You obviously need reconstruction of speech where it has to be hidden Markov model, right? And that only is the combination. GMM cannot do it for you in real time. It's obvious. It can only fit in and give you what is a word. It cannot tell you anything more than just reconstructing a word. But if you are to reconstruct a sentence, you need a set of words to be decoded, and you have to move from one word to another word and another word and so on. And how do you find out gaps between one word and another word, right? You will need to have some sort of silence detection as well, and ability to find out which was when did this word stop and when did the next word start. All of that is actually nicely captured in GMMs rather than in HMM systems. So HMM essentially is able to give you features to phoneme, and the language model essentially gives you the words to sentence. So essentially, it's more to do with the HMM there. All right, Biswajit Singh, many thanks, sir. Is there any chance to conduct system design course related to IoT? Biswajit, I am not sure at the moment if I can answer this question. The first course on design for Internet of Things has more or less moved on, and we need to look at newer things which are happening because this is a fast changing IoT area. So let's see. At the moment, I don't have plans, but if there is one, please do look out for the websites in the coming months, maybe sometime next year. So Anand, let me take the next question. Localization using IMUs, the process to check if the phone is held left, right, left hand, right hand. Answer is should be accelerometer and not gravity, I suppose. Well, acceleration can also be used with the detect of left and right hand, because accelerometer in phone also takes G factor of 9.8 meters per second square into account, which is indeed the G gravity. So essentially, you could use. That's the real takeaway from all what we are saying. All right. So next is all right. So next move on. Biswajit, how can we measure fuel level using microcontroller? I am making a smart car dashboard which will give the parameters on the screen, but roadblocks are due to vibrations, fuel level not showing. Oh, amazing. Yeah, this is a problem, Biswajit. This is not going to be an easy problem. You basically want to show fuel level using a microcontroller. I'm sure microcontroller cannot measure fuel level, can calculate the fuel level based on what sensors are giving to it. So you need a fuel level sensor. I did not see anything with respect to your sensor at all. Can you talk about what sensor you're using for level measurement of liquid fuel? If you can say that, I can perhaps think a little bit more. But let me just take it, assuming that you have a level sensor somewhere. Your problem is vibrations in the fuel tank. The fuel level is not showing up. This is not the right answer at all, Biswajit. I don't see why vibrations are creating a problem for you. As long as the fuel sensor is deeply embedded inside a existing tank, it should be able to measure the level quite accurately. I don't see a problem there at all. This problem you are mentioning may be due to other reasons. Just check how you have mounted the fuel sensor. Is it touching the body of the fuel tank? In which case it may be subject to some vibrations. It is because of swishing inside the fuel tank. That is another problem. Swishing means as you drive, the fuel inside will be moving, will be oscillating inside, right? Suddenly it will rise in level. Sometimes if it is a road bump or a hump, there'll be a swishing inside the tank. Because of that swishing nature, you will not be able to measure accurately. So you have to use other sensors to measure perhaps on a, let's say you co-locate it with an accelerometer, you now know that the road is flat, there is no change too much in acceleration, then you detect a flat road. At that instant, you ensure that your sensor is embedded inside the fuel tank, then you should be able to measure fuel quite well. So if you can reframe the question, I hope I'll be able to answer it better, but I think this is your problem. Vibration, because of vibrations you're not able to measure is something hard at the moment, because I don't think vibrations actually can create a problem for you. Yes, one problem you may have is that because of vibrations you may not be able to read the fuel value accurately because of swishing inside the tank. But beyond that, I don't think you will have any problems. Okay, so let's move on. Dheeraj Mishra, I'm controlling the drone with the help of IoT, and I want to implement the mixture of IR and X-ray on the drone with camera to identify the people that are buried under the snow during rainfall. Okay, fantastic question. What all ideas you are getting is outstanding. Really, this is excellent IoT question. Really hard problem to worry about. Dheeraj Mishra, you have to do a lot of measurements before you actually go and do anything on the drone. First of all, ensure that you create artificial snow, put some hot body inside that snow, and see what frequency actually penetrates snow. You cannot arrive at IR and X-ray without making proper measurements. Maybe they'll get attenuated. So what is that frequency of interest by which you can design your system will be very important. Therefore, I would not like to say that IR penetrates snow or X-ray penetrates snow. You should make a proper measurement and see what is the depth of snow that you want to attack. You can't be talking of piles and piles of snow and a human buried under that. That may not be a very feasible idea. Or maybe it is. That's what you have in mind. Or is it 6 inches or 8 inches above that the person is buried? Or is it 1 foot? Or is it 2 feet? You have to know at what is your technical specification you want to lay out, and at what depth inside the snow is the human buried, and you want to make a measurement. I can give you some ideas on how you can do this. For a human being, what you can do is you can take a Coca-Cola or a Coke or a Pepsi hot bottle and fill it up with some warm water, something close to human heat, and bury it inside snow. Somehow you have to make artificial snow. There are ways by which one can do that. You can create this artificial snow, put this hot water bottle inside, Coke or Pepsi bottle deep inside, and then use a sort of a radio system by which you can change the range of frequencies. Maybe you can start with what you could start with perhaps is somewhere in the sub 1 gigahertz range, 800 megahertz onwards, and then you sweep over a range of frequencies to see which one of them will be able to give you a good information. Essentially, you have to build a radar from what I see. You're going to throw some energy, RF energy, on through the snow deep inside, so that the human being, it will go and touch the human being and it will reflect back. And only then you'll be able to see, based on some pattern, whether there is a human being buried or not. So it's, I think, going to be a radar technique. So you could look up radar techniques. You can look up what frequency penetrates snow, and how do you build a low-cost radar, and all of that will now sit on the drone, and then the drone will move. So I don't think you should go into the drone part first. You should worry about your sensor first. Your sensor is absolutely critical. Okay, so build your sensor, find out what frequencies will give you this nice radar signal back, and after that, after proper testing and all of that, then you can put it on the drone for successful trials, for initial trials, and then finally make it as successful as possible. Okay, Biswajit Singh, I go to the next question. Speed breaker fuel will not be, that is right, Biswajit Singh. I hope you are just asking me in continuation. You are right. If you put a speed breaker, what will happen is swishing will increase inside, Biswajit Singh. The fuel inside the tank will be swishing all the time. Therefore, it will not give you a proper indication of the level. It will not be in stable position. That's why I said you should put it along with a accelerometer, read the accelerometer's value. Moment you find it is stable, you start reading off the fuel values. So I think that's what it is. All right. So let's read Vimal Mishra. Vimal Mishra, upcoming year, which communication protocol will prefer most in IoT? Again, Vimal Mishra, you have to look at the previous course I did. This is not really about protocols. But I will still like to answer you because you are also enthusiastically asking me questions. I think there is no one single protocol that I can think of. However, I want you to take a lot of encouragement, courage, and you can have your collars up today evening that the protocol, open source protocol that has been widely tested and used is in our own Aadhaar card system, which is the AMQP. Okay, in the last course, if you look up carefully, Ms. Tejaswini had set up a nice demo for you. Please look up the previous course, Design for IoT. There is a nice demonstration on AMQP. It is perhaps the protocol which most often in industry environments people use. And as you can see, Aadhaar card and its success is a typical example of the fact that AMQP is applied there. So that's the my answer to your question. Mayank Tyagi, Android project you shared for practice in localization of IMU sensor is not opening in Android Studio. It's a verified code built in the Android Studio, but you can check once again with your installation. This is the input I get from our colleagues here, and therefore it should work. It should work. You should check with the manifest file whether it's present in the source code. Rather, this is the manifest file. It's present in the source code. Is shared or not? It's shared, I think, and therefore it should work. So in summary, this should work. There should be no problem at all. Is a working nice code, and I think it's critical. I mean, this is one place where you can get some free code as well. So you should kindly try. So this. So Mayank Tyagi, your next question is in the Android project. Some files are missing, like manifest file. So that I have already answered. It is there in the source code that is shared. So please check again, Mayank Tyagi. Let's move on to the harder questions. Deepali Gohil, sir, I missed the initial part of the session. Can I get this on your YouTube later? I am not sure what is happening. Deepali, I'm sure it should be available. But never mind. Deepali, you can ask questions. Deepali, I'm here for the next 20 minutes or so. We can take more questions. Anita Devi, Kugal Raj, in the next generation automobiles, how can a robo identify which robo sends the message? When there are lots of robots sending the message at the same time. Wow, this is outstanding question. So let me understand. You're talking about I'm not sure of context, Anita Devi. It's a good question though. You mean to say there are several robots inside the automobile, or there are automobiles which are sending robots? There are several robots inside the automobile, or there are robots from outside which are sending messages to a robo inside. This I'm not sure. So let me see a connected question you have asked. How the decision is taken when both robo come at the same speed? Anita, can you improve your question? Are you referring to each vehicle is a robo? Is that what you have in mind? I think that's what you have in mind, and I think you're trying to connect to the demo that we showed you on the open source tool. Okay, so if that is indeed the case, I should look at your question again. Which robo sends the message when there are lots of robots sends the message at the same time? Oh man, this is outstanding question. So this is in the context of so what's the context here? The context here is platooning, I suppose, and the question could be on platooning, or it could also be an intersection crossing. Okay, it's on intersection crossing. This problem may be related to intersection crossing. So now, next generation automobiles, how can you identify How can a robo identify which robo sends the message when there are lots of robots sends the message? Wow, this is. What do you think, Anita? This is. You're right. This can happen, no? There can be many vehicles on each of these roads. If you're talking about an intersection, what do you think should happen? Let me give you an analogy, Anita, and I can only go give you an analogy and sort of divert that question because it's easy to give you analogy. When two planes are flying at the same height, okay, and they're coming dangerously close to each other, there is an algorithm which is something that goes beyond what pilots can do, which decides to change the height of one plane and the other plane goes at a one plane takes lower height, the other plane takes higher height. That way collision is avoided. You need smart algorithms, Anita, which are built into these systems essentially to take care of such situations also here. But this is not directly related to your question. Here, I suppose if you are looking at the robots which are exchanging information for a safe intersection crossing, you may have to use some other metric. It could be if it is communication, I may look at signal strength, for instance. That message which comes from an automobile which has the highest signal strength is the one I will take as the one that I want to consider. This could be one way. Another way is I may want to on the spot I may localize each one of those robots which are there. That is, this car will localize all of the robots which are there and then take a message only from that robo which it has to worry about. So you can also look at this whole problem as an online um, localization problem on the spot at high speed localization and considering only those messages, or you have to build in resilient algorithms which will take care of situations where only two messages or important messages are accepted. If there is too much of confusion, Anita, I think the best way is not to regard those messages at all and go manual, take over control manually, and then cross the intersection and put it back to auto. These are things that I can at best say something um, about this question. Vinod Hegde has put a small remark here, and he thinks that there is a good possibility that don't rely only on these messages, rely on other sensors, maybe a lidar. Okay, message coming from the distance estimation from a lidar, maybe distance estimation from an ultrasonic sensor. Some other sensor will be required in order to improve and identify this. But Anita, this is a very deep question. I really like your question, and you can see that there is a struggle even from my side to give you a proper answer on this. I really congratulate you on your very deep thought on this question. It's really a outstanding question. But there is no straightforward answer to this, Anita. You'll have to look at the situation, and based on the situation, you may have to make a decision out there. So that's it. So having said that, I would like to go on to Deepali Gohil's question. Traffic signal simulation to get the toll charges from RFID card. Can you guide about which kit out of available can you provide security for this project? Oh, okay. So this problem of traffic signal simulation to get the toll changes through RFID, you're combining traffic signals with toll charges. This I am not clear, Anita, Dipali, but I can tell you this that the use of RFID for charging the toll is an old story. It may not have happened surfaced in India, but it is an old story. Several tall roads in the US. I have seen many toll roads actually use the RFID tag directly and then open the gate of the toll booth to allow the vehicle to pass. The real challenge is you have to read the RFID tag, which is stuck inside the windshield. That means the windshield has some thickness of some and your tag should be able to be recognized by the reader by passing radiation through the glass. This is itself not an easy thing. We have been doing some tests in the lab to find out what is a good distance to read across glass, and I think you need some real special tags and a special antenna to read these tags. So tags are of different varieties for different applications and so on. So this perhaps is a question right there. All right, so let's move on from there. I can't guide you into anything more than this on this front. Security of this project, it is a RFID can be very secure. You may want to store information of whatever is there on the tag in a secure manner, and only those toll booths which have access to the key can read the data from the RFID tag and decode that data and all that. So that is not a problem. Security very much is there in the RFID system. All right, so let's move on. Dipali Rane, for old age person, if you wanted to identify fall detection, which is the best sensor? Very good question. Again, another application for in the wellness being space. Well, people have used different type of sensors, Dipali. One simple option that you can look up would be an accelerometer. It's noisy. You have to look for very good signatures to identify that it's indeed a fall. How do you differentiate a fall of a person holding a phone to that of a phone falling? Phone can also slip out of your hand and can create a signature very similar to that of a person falling. So it will require some real good signal processing effort. If and we are making an assumption here, right? We are making an assumption that a person who is falling actually has a phone in the pocket. Only then that accelerometer business actually makes sense. But that's not necessary that you should use an accelerometer. You can also equip your home with cameras, and camera can actually detect a fall in a fixed infrastructure system. And very good video analytics are possible today. Image analytics are possible today to detect fall of humans inside homes. So I would say that you should examine camera sensors, you should examine accelerometers. You can also examine RFID systems in the following sense that the whole floor can have RFID mats which are rolled over the floor, and every time a person falls, and the RFID signal at the reader would change, and that would create a signature which you can capture. So you can use RFID mats for the floor. You can, from floor to floor, you can have RFID mats. You can have camera sensors which can detect fall. You can have accelerometers which are embedded in phones. Hopefully, phones are being carried by this age-old person or old age person, or you design some sort of a accelerometer or a wearable device for the person which has the sensors embedded in it, and you look at signatures coming uh, from those systems. So Deepali, that's the answer for you. You could use several sensors, both fixed infrastructure as well as those sensors which are body sensors to detect the fall of the person. Okay, Vimal Mishra, how can we reduce power requirements in long-term RTOS IoT product? Vimal Mishra, I mentioned to you clearly many times, not you, but the whole class, that this is really not a course on systems and systems building. So if you don't mind, I would like to skip that question. But I must tell you, I don't like to disappoint you, Vimal Mishra. So I'm going to answer this question in any case. See, if you have a sensor, right? You have a sensor, and sensors are typically analog by nature. These sensors, they will be, let's say, sensing something, and that may be connected to an ADC port, okay? Because you have to connect it to an analog to digital port. Now, one way is you take the sensor and connect it directly to the analog to digital port. The other way is you connect it to, let's say, a comparator, okay? You connect it to an ultra low power comparator. And now what you do is, by the way, what I'm telling you are all you can do. Most microcontrollers have a comparator inside. You can use those comparators. So what you do is now your output from the sensor is connected to the comparator. And you program the comparator in code, which says only if the signal gives me above a certain threshold, I am going to trigger storage of the data in the controller's memory. And that part, you can do it with a DMA. All right. So now you see CPU, you can put to deep sleep. Put the CPU to complete deep sleep. You have a sensor connected. The sensor is connected via to the ADC via a comparator, and DMA is waiting. And moment the threshold crosses, that means there is a valid detection. The comparator switches on, gives an output. Moment that is given as an output, the ADC is taken. ADC value from the DMA takes over the ADC. ADC value is sampled and then stored into memory. And after that, you're triggering the CPU and informing the CPU that I have a sensed value for further processing. So now you see your power, which is V times I plus CV square F, which is the overall power, that is static power and the dynamic power, can completely be reduced by simply putting the CPU to deep sleep and cutting off power completely to the system. In fact, even oscillator circuits can be cut off. Just because you want to sense, you don't want a controller to be on. And today DMA can do all of that for you via this comparator. So Vimal Mishra, that's the answer to you. So RTOS, with RTOS, you can manage all this very, very well. Okay, so that's the point. Okay, Mansoor Ahmad, next question. Dear sir, libraries seem to find it hard to identify misplaced books in racks. Some papers propose using RFID to solve the issue. I feel employing computer vision might give a more efficient solution. Mansoor Ahmad, you are right. There are multiple ways of solving this problem, for sure. If you do RFID based, you have the advantage that you need a reader to go around the complete library. So, and you need a good localization algorithm, like the one that we discussed in the class, the hyperbola based algorithm. And the reader should perhaps mounted on a robotic platform should do this identification and come back. This is possible, sure, Manzoor Ahmad. People do this regularly in departmental stores. At the end of the day, let's say, shops like Walmart or Metro or any one of them, just before closing down, they set up this inventory mechanisms and then go away, so that they take 3 hours, 4 hours and identify different items inside these large warehouses, and then they're able to localize and you can put things back in order. However, that's not the only solution, Mansoor Ahmad. I completely agree with you. Computer vision based systems are very much around. You need very good, accurate and high resolution cameras to identify the name of the book, because you should be able to read it off when you flash the book. Often library books have a wrapper which are identical for all books. So how will you read the wrapper and make out which book it is difficult for you, unless there is a title of the book, and the title is often hidden inside in the inside pages. So all wrappers will look alike, all books will look alike for you. You may find it hard. But Manzoor Ahmad, it will depend largely on the problem setting. Why should you wrap it? You may as well put the textbook without wrapping it. Yeah, you can do that, but if it is not a hard bound, after it exchanges 3 or 4 hands, you're bound to have a problem with that book, because very soon if you don't have a hard bound, the wrapper will simply peel off. So hard bounds are very expensive, Mansoor Ahmad, to buy. They can be at least 30% more expensive than regular soft bound things. And by binding it, you have another problem. If you don't bind it, you have another problem. Therefore, this is really a hard problem. But there are multiple solutions. You should not go by the fact that only RFID can actually solve, but it's found that RFID can actually solve this problem to a large extent. See, it's not only, it's like this, right, Mansoor Ahmad? Think about the following situation. I go to the library I go to the library, I borrow a book from the library, okay, and let's say this is an RFID based technology. So I go to the charging discharging desk. The lady there or the gents there will charge the book, and I carry the book and I move out of the library. I go back to some other place where I am sitting, my department, my lab, wherever I am. And now, after 15 days, the librarian wants to know where the book is. Okay, physically wants to know where the book is. Now, one sure shot possibility is you can track it down if it is RFID based. Let's say the place where I sit also has an RFID reader. Now the reader can actually read the book which is on my table. ID can be read off easily. Even if it is not read, supposing I left it at home, yet there is information that so and so borrowed this book because the charging discharging also contained my information, the person who borrowed that book, and this book will now be charged against that person. Therefore, getting real-time information about tracking the book is also as important as putting back misplaced books. And therefore, tracking is something that you can do very effectively with RFID systems. I am not biased to the RFID for this problem because Mansur Ahmed, your point is right. At the same time, think about what is it you want to solve. What is the application on hand? What is it you want to solve before you arrive at such conclusions? All right, let's move on to Biswajit Singh. Sir, how IoT can be optimized with respect to a environment policy, because in future devices will be connected through internet and it can make adverse effects. Is there any measure to reduce this radiation? Biswajit, I'm not clear what you're saying. Are you saying that IoT devices are no inducing radiation? Will be connected through internet and it can make adverse effects to be optimized with respect to environment policy. Biswajit, I think I would like to hear a better formulation of your question. I'm sure you have something very important to say, but I'm not able to follow at the moment. Are you referring to IoT sensors spoiling the environment or corrupting the environment, or what is the take? I'm not clear. So let's look at that. If you can reframe it, I'll be happy to answer that question. Dipali, thank you very much. Also, I hope you are enjoying the whole thing here. Now let's move on to Upadhyay's question. How can you implement video calling feature using Raspberry Pi? It would be better if you suggest some GSM module which will be best suited for my purpose. Video calling feature using Raspberry, it would be better if you could suggest some GSM module which will be best suited for my purpose. GSM bandwidths are insufficient to run a video call. You will need packet-based networks in order to carry video messages. Typically, you need an internet connection which is offered by your operator. It should be a 3G connection or so. Then there is a possibility to do these video calls. There are many applications. Where do you want to build it? You take your smartphone. You have Google Duo. You have Skype. Now I think you have WhatsApp, which can do video calling. Several of these applications have it. I don't see much motivation for you to do this project. Instead, see how you can build on existing projects which are already out there. But nevertheless, your question is, how do I do it on Raspberry Pi? Raspberry Pi will not be able to do anything for you. And this will definitely require a connection. You need an internet connection from the Raspberry Pi. So maybe you need a Raspberry Pi Wi-Fi module which you can install onto one of the USB ports, and from that USB port it can connect to an internet connection, and then perhaps you could do a video call and connect. But you seem to suggest that it would be better if you could suggest some GSM module which will be best suited for my purpose. I'm not sure. As I said, GSM will not be able to handle the kind of data rates for running a video call. You may want to look at 3G, 4G, and so on. All right, so let's move on. Deepali Rane, thank you very much as well. Great to have you on the course. Nishant Sharma, Which is the best technology which can be used for automation of parking systems? Oh, this is a nice application. Automation of parking system. I was planning to do something in that space in the last time, and somehow we could not implement it. So this is not simple, Nishan Sharma, but you should try. First thing you should know is you should know the let me see what all you have to do. You have to find out between two cars or two vehicles what is the gap available. Whether that gap is sufficient for your vehicle to go and sit in there, right? So you have to do a lot of estimation in real time. Lot of geometry will be required. Perhaps camera sensors may be useful for estimating the distance available between two cars and whether your whether your car can actually fit in there. Once that estimation is done using a camera sensor, you will need another sensor for guiding you into that slot. So that can be ultrasonic sensors and other related sensors, and that might help you. But nevertheless, very interesting project. You should try, and if you're serious, you should try and implement it. All right. So, Vimal Mishra, thank you very much. Also, thank you for very much being on this course. Padmavati, thank you for your valuable time. I um, I'm also happy to have you on this course, Padmavati. I wish you a very bright career as well. Mayank Tyagi, sorry to interrupt you again for the same question, but now on this link of Android project for localization of IMU sensor has only three folders and the manifest file is not there. Okay, so Mayank Tyagi, um, we'll have to check. We'll have to check from our end, and we will try and address this problem, Mayank Tyagi. Soon after the course, Miss Teji and the team here will look at it and then come back to you. Sorry if you are not able to find that file. Maybe there is something else. We will check this and come back to you, Mayank Tyagi. We are so happy that you have so much of interest to work on that IMU-based localization, and indeed, very good that you have so much interest in this. It's really overwhelming, guys, that you have so many questions to ask, but there's also this time limit from my side. As you know, I've been talking non-stop without full stop and comma for 1 hour, and none of my colleagues here have ever had a chance to. So you must see them once to see and see how much they have participated and how much interest they have. We'll do that soon, but somewhere we should stop you guys typing questions away. Okay, so let's say Biswajit, that's the last question I see down below, which should be the last question. And let's see if I can answer the remaining, starting from Biswajit's question soon after Mayan Tyagi. Okay, Biswajit Singh, due to increasing no internet connected device, there must be electromagnetic radiation problem due to large number of wireless devices. What will be the effect of environment and how to minimize this problem? Wow, Biswajit Singh, this is a really deep question. You have asked the question in a naive way, but this is a serious problem, Biswajit Singh. Many researchers are working on this problem. The problem that you have posed is in the area related to coexistence of wireless devices. Try a very simple experiment, Biswajit Singh. I am very keen that you should try this. Let's say you're listening to Bluetooth low energy music streaming from your phone. Okay, you should be music streaming from your phone to a BLE device. Okay, so your phone is playing a music and you have a, let's say, a ear device which is BLE enabled, or you have a speaker which is BLE enabled. You start streaming nice music there. Okay, now as you are streaming data, it's all fine, it's all listening, it's playing out beautifully. You have a wireless music device and all that. At the same time, with your wireless mouse, try to browse the web. Okay, you will see very jerky motion. You will see a lot of jerk. You will see that data packets are being lost, and whatever you're trying to do with respect to that mouse is not moving properly, and all that. Very simple experiment, right? You just have a mouse, wireless mouse, and you have this wireless BLE device from which you are listening to. music. Both of them should be together. You must be doing it together. I tried this, and that's why I'm sharing my experience. Huge amount of loss, not only on the screen but also on the music. Many times there'll be a jerk in the music. Clearly, one Bluetooth low energy device is interfering with another Bluetooth low energy device. This is as your problem. Forget about all what you've written there, Biswajit. It can happen right today, right now, if you try this experiment yourself. So this electromagnetic radiation is indeed a problem. Bluetooth low energy has the advantage of doing frequency hopping. I will pose the problem differently and I will answer some part of it differently. But at the same time, I can't answer your question directly. If you take Wi-Fi and Bluetooth, okay, Wi-Fi and Bluetooth both work in the 2.4 gigahertz frequency range. Now, as long as so Bluetooth has the ability to say that, oh, if there is so much of interference in these channels, let me cross over and hop over to those frequencies where Wi-Fi is not present and avoid using those channels on which Wi-Fi is directly mapping. So that way, it is able to hop over to those frequencies which are free from Wi-Fi. But if you have 3 access points which are completely mapping into the complete Bluetooth range, then there's only one possibility by which you can escape any interference, and that is with respect to those 3 advertising channels. These 3 advertising channels do not overlap with anything with respect to Wi-Fi. They are independent. But that's not your question. The question is, how do I avoid this electromagnetic radiation? Okay. Partially, I have answered Wi-Fi, Bluetooth. Bluetooth, I have not answered, which is also another problem. That this is something that people have to look at seriously. One sure thing that you should be looking up is shielding. Shielding is a major advantage. You should be able to cut off those which are coming from other external from the ambient and shield these devices against any electromagnetic radiation. Now it comes to a very important point. If you look at electronic systems which are built, and if you don't want any electromagnetic radiation to bother the functioning of a critical part on a electronic system, they actually put a electromagnetic shield on top so that it cuts off all radiations. So one option is to do that. But Biswajit, your question is very large. There are no answers directly to answer you. Hopefully, there are some mitigation mechanisms between Wi-Fi, Bluetooth, and so on, but it's not completely foolproof. One trivial answer to give you, Biswajit Singh, this is the problem you will have if you use ISM band frequency. It is free for all. Many devices, many companies will use it because you don't have to pay for license. One way to avoid, problems of electromagnetic radiation is to use licensed spectrum. It isn't that radiation will vanish, but at least interference from electromagnetic radiation will be much lesser because nobody can use that channel unless you are, you are allowed to use because it's a licensed spectrum. Like for instance, how many times have you had the problem of call drop when you're on a BSNL call or on an Airtel call or on a Vodafone call? You won't have had that problem. The spectrum which you're using, wireless spectrum, when you're making a call or when you're getting a call, is actually being occupied. And that's what the operator has made available to you. So that will actually be locked up during the time when you are using it. Again, it's not answering your question. You're asking about electromagnetic radiation problem, right? Radiation problem, as I told you, is an issue. But don't worry so much about electromagnetic radiation. I'll give you a simple analogy. Many people have said electromagnetic radiation creates cancer, right? There is no proof that cell phones can using too much of cell phone creates cancer and all that. That's all unscientific. There is no proof at all as of today. Okay, there is no concrete proof. Problem is, if at all there is a problem, the problem you won't get from a cell phone tower, radiation from a cell phone tower. The problem will come from your own phone when you're talking. It is closed talk, perhaps 1 watt of power being radiated directly into your brain when you are talking, not so much when you're receiving a call. The tower is far off. So don't worry about all these radiation issues. If you have to move on, you have to handle it. There should be mitigation mechanisms. For electronic products, you have to put these shields. And for non-electronic systems, you have to somehow manage to go over this radiation problem. But yes, this is a genuine problem though. Nishant Sharma, I'm currently working with Pi camera module and ultrasonic sensors, magnetic sensor. Very good, Nishant Sharma. That's very good for you. This is I'm sure this is in continuation to your previous question. So thank you very much. That's a nice thing to do. Upadhyay, thanks a lot, sir, for your response. I'm building a surveillance system which will stream the live feed onto a user cell phone. Fantastic. Upadhyay Sharma, please look up software defined perimeter. This will help you to build your surveillance systems in a much more secure manner, and so that your surveillance system and your stream data is not available to those who should not get access to those systems. So that's a very important thing. Nishant Sharma, sir, can you tell me what is the best technology by what I can transfer data, what I can by what I can transfer data of sensors? Nishant Sharma, question is not very clear to me. Best technology by what I can transfer data of sensors? You mean communication of sense data, or what exactly is the meaning? This is not clear. You mean with respect to the Pi camera module and ultrasonic sensors and magnetic sensors? It's not clear completely. So let's look up Nishant Sharma's questions to fill in the dots. Which is the best technology that can be used for automation of parking system? Yeah, that was the question he had originally posed, and then there were a lot of questions down there. Yeah, so he's using camera module, ultrasonic sensors, magnetic sensors. Nishant Sharma, you almost got the sensors right. This was also my guess, and you have actually used those sensors. Very good. So that's nice. Best technology by what I can transfer the data of sensors. Where do you want to transfer this data, Nishant Sharma? You need a cloud. You want to process data on the Raspberry Pi. What is it you want to do? I'm not clear, so I suppose you may want to ask your question slightly differently. You can also ask on the forum. We may be able to clarify. Vishwajit Singh, many thanks, sir, for connecting with us. It's very good learning session. Thank you very much. And it's also great to have you on this course. I wish you all the best as well. Nishant Sharma, yes, sir, I'm looking for those sensors only. Very good. So I think you have these sensors. These are good sensors. See, camera module, please recall what we discussed in the modules. If you are using a USB type of cameras, what you should do, go back to that module very carefully. Camera calibration is a very important thing. Don't forget the camera calibration part. Sometimes you have to learn the lessons the hard way. We know Hegde was there. He was telling us how hard this problem was and how we made it finally work against several lighting conditions and so on. So guys, this is important. So let me now, what I'll do is, I will just pan my screen to all our teaching staff here, teaching assistants who have been here, and let's see if you can get to them. So let me see, can I move it? Yes, okay. So this is Vinod Hegde, the expert who has spoken to you all about camera calibrations and lidars and so on. Sanmai is here. I'm not able to get him right. So let me someone who can practice it here. Tanmay Patel spoke to you about, did a lot of work for you on, right now he's doing on pollution as well and air quality. And he is the one who has worked with you on the RFID systems. And this is the guy who did nothing. So let's move on to the person who did a lot. And this is Tejaswini. She was in her second innings now. In the first innings, she did the design for IoT course, and this time she has been the main anchor for this course. We have looked at almost all modules, working very closely with me and driving me, being she's the real taskmaster out there. Praveen Rajgopal has been the one who has been working on speech to text, and Nitesh Nayak has involved himself in almost all modules, including the module on RFI, on the module related to LiDAR. He is the one who, I can remember that. So he is the one who has built the LiDAR systems and the Fubuki systems and so on and so forth. So he is the one on the on those systems. So folks, hope you'll have a good one more week to go, before which you have to take the exam, and you'll have one more module to go, and that will be on the first responders network, and hopefully a lot of things from that can also be used as part of the course. All right, so I've shown you the faces of all of them. Nishan Sharma, thank you so much for helping me. I'm sure I'm very happy to help you. And Shubham has a question. Shubham Soni, sir, I have a problem. Shubham, shoot. Ask the question. Let's see where if we have solutions for you. Shubham Soni, you can ask the question. There's one more question to Shubham Soni. I want to answer Shubham Soni's question. Oh, is it stopped or what? Is it live? Yeah, okay. So let Shubham Soni ask him ask. I think it's him. ಚೆನ್ನಾಗಿ ಕೆಲಸ ಮಾಡ್ತಿದ್ಯಪ್ಪ ನೀನು 1 hour ಬಡವಳ ಅಂತ. Shubham Soni, I didn't see the question from you. In view of that, you could always come back on the discussion forums, and we can take this question out there. All right? All right. So thanks, folks. And let's now wind up the this live chat and move on. And here's wishing you very best in your career, and all the best for your exams in the coming week. From all of us here from the Indian Institute of Science, thank you very much.